And we will also be sharing the information about the YouTube channel as well. If you have any questions, please type them in. You will not be able to speak. And we are constantly monitoring the chat room. So if there is anything that you ask that needs Deepti's attention, we will definitely bring it to her. I will also be turning off my camera to conserve the bandwidth. Okay. Thank you, Deepti.
Thank, thank
Go
you,
on.
Paresh. Thank you so much for having me today. It's a long day for me here today. So many things happened, but yeah, no matter what, I wanted to present here um, and continue to educate whatever I know. I'm not an expert, but I would like to share whatever I know. So I hope you enjoyed this session. So today I'm going to present on performance improvements in SQL Server 2022. So let's get started. A little bit about me. I'm a database administrator, having about 8 years of experience as a DBA, and also I'm a Microsoft Data Platform MVP, and I'm a co-organizer for a couple of user groups for the Data and AI South Florida user group, DEI, Diversity, Equity, and Inclusion user group, Data TGIF, Data Thank God It's Friday user group from Switzerland. I do that along with my friend Kai Sotter. And I recently joined another user group, which is known as Cloud Data Driven User Group, as well as the Future Data Driven Conference. So we are going to come up with Future Data Driven Summit 2025 very soon. So it is a free online conference. If you'd like to um, register, you can go ahead and search on YouTube on anything like Google. You can find it. We have a page on that conference. So apart from that, I have my contact details here. I'm very active on LinkedIn as well as Twitter. And also, I usually blog on dbanuggets.com, where I usually blog about SQL Server and Azure SQL. If you'd like to see, please go ahead and visit that. So, as an agenda today, I'm going to talk about I'm going to talk about actually all the things that you are seeing on the screen. But specifically, I'm going to show you the demo for the query store hints as well as the parameter sensitive plan optimization. But I'm going to talk about a lot about the rest of the advanced features in SQL Server 2022 as well. So, as the first one, when you see, we are going to talk about the query, like the improvements in SQL Server 2022. So, the first thing, because I talk a lot about query store, one of the advancement in SQL Server 2022 and in Azure SQL is Query Store hints, which got introduced in SQL Server 2022. Query Store got introduced in 2016, but Query Store in 2022. So we are going to talk about that. But as an overview, like how you need to know before knowing Query Store hints, you need to know how Query Store actually works so that you can better work with the query store itself and as well as use hints. So I put this slide together just to give an overview. So first half of the slide will show you how actually query runs in the engine itself. But what if like you are using the query store? One of the advantages of using query store is you can force the plan. So for example, you have a store procedure where it is performing well, and suddenly, for some reason, it created an entirely new execution plan and the performance is not good. So, in that scenario, if you have query store enabled on your database, you can go ahead and see back on in time. You can go ahead and see what was your good plan as well as what is the current plan, and you can choose the plan. You can choose and force the plan so that the next time the store procedure runs, no matter what parameter it uses, it will go ahead and create or use the same similar execution plan, which is very close to that force plan. So half of the slide will show you how the regular query runs, and the rest of the half of the slide will show you how the actual query on which we forced a plan will work behind the scenes. So let's say we have this query, any query running on the SQL engine. When it is running for the first time, it will check whether it is running for the first time, right? And then if it is running for the first time, then it will go through the compilation and optimization phases, and it will generate a new execution plan. But if it is not running for the first time, then it will go ahead and see if the plan is already in the plan cache. Now, there can be reasons where the plan might not be in the cache. For example, when you restart the SQL Server or when you rebuild the statistics, SQL Server will go ahead and force the queries to build a new execution plan. So in any of these instances, then it will go through the compilation and optimization phases again and build the new plan. But if there is a plan already in the cache, it will go ahead and use that plan from the cache, right? Until now, you have seen the processes that actually happens on the SQL engine regularly on any query. But here, the next step, it will check for the recompilation when it is actually using, if when it is actually running the query where we actually forced a plan. So in that phase, it will go ahead and check for the recompilation, meaning it will go ahead and check whether that plan that it has actually taken from the plan cache or the plan that has actually been built newly, whether it is similar to the forced plan. Because let's assume we forced a plan by using the query store. Now, not all the time the plan that got generated might be similar to the force plan. In that case, it will go ahead and apply, and again, it will go through the recompilation phase and then create the plan which is similar to the force plan, and then it will apply that force plan. But most of the time, it will create the similar plan to the force plan. In that case, it will move ahead. So before going to the execution phase, there are some memory stores that you have to remember when you are using the query store. When you enable the query store on a database, again, it's a database level feature, not a server level feature. So if you want to use the query store, you need to manually go ahead and enable on each database you want to use, right? So it will go ahead and collect the plans like inside the plan store, the query text and the query plans will be collected even before the query goes to the execution phase. And there is also another memory known as runtime stat store, which will be enabled when you enable the query store on the database. Runtime stats will be also collected. So if you are not familiar with the query store, when you enable the query store on a database, all your queries along with your execution plans, the runtime stats as well as the CPU memory IO, all the resource consumption information and the query text query plan, all of these will be saved. So that is the main advantage, right? Once you enable, it will track all of that information. So here, the query text query plan as well as runtime stats will be collected. Always remember that the runtime stats will only be collected once the query goes to the execution. Query itself have to execute to even collect that information, right? So that's the reason after the query executes, the runtime stats will be collected, and based upon the interval limit, by default it is 15-minute interval. Every 15-minute interval, all the collected information in this memory stores will be pushed out to the query store schema, which is on the primary data file of the database, and you can't change that location. It should always be that. So all of these processes will happen asynchronously. So um, that's how the forced plan will be used, and like how it will be actually collecting the data and how it will actually collect the data in the query store schema. So once the data will be entered into the query store schema, there are certain system views where you can use to pull up all the information that is being collected. So you it the like by looking at the previous slide, you might be thinking, okay, but what is the difference between plan cache and query store? Plan cache will also save the query plans, and query store will also save the query plans, right? But there are certain very drastic differences between both of them. Plan cache will always collect the latest plans, and when you restart the SQL server, or everything will be lost from the plan cache, right? But with the query store, you can set up the limits and you can configure in such a way that only when the cleanup policy is hit, which is by default 30 days, then only the old unused data will be deleted. You can control that and you can see the over time data, like you can go ahead and see the data over time because that information is collected. But with the plan cache, only the latest plans that are being used will be collected. And whenever there is a memory pressure, the first thing that engine does is to clear up the plan cache, the old unused plans from the cache. But with the query store, that doesn't happen, right? It will collect over time and then it will save that information in the memory until the flush out interval will reach. Once the flush out interval reaches, it will push that data to the disk. So those are the main differences. And also it is very difficult to pinpoint and to see what is going on with the plan. If you only rely on the plan cache, it is very difficult to know why the plan has changed. You can think that mm, 1 minute. You can think that if you are using the monitoring tools, we will also have all of this information. So what is the difference? The difference with the monitoring tool versus query store is that as the query store is inbuilt within the SQL server, you can go ahead and force that plan. But by using the monitoring tool, you can't do that. Of course, you can get every information, resource consumption information, and who is blocking who, and all sort of that. But by using the query store, that's one of the advantage where you can force the plan. You can use the query store hints that I mentioned. So the other advancements, right? Not only the query store hints, but also there are certain other advancements in query store, especially in 2022, SQL Server 2022. In SQL Server 2022, query store is enabled by default. If you are creating any new database, create new database, then query store will automatically be enabled on the top of those newly created databases. Now, if you are migrating from the old version of SQL Server to the newer versions of SQL Server, it will not make the changes automatically. You need to manually enable the query store if you do not have it on already on the old systems. So you need to manually check whether it is turned on the newly created sorry on the new environment once you migrate. And also previously there was no internal limit for the ad hoc workloads. So it used to overwhelm the um, query store space. Once you configure it, you have certain limit on how much query store can use the space. So as there were no limits, um, it used to spill up. It used to use that data very quickly. But with this SQL Server 2022, they have that internal limits. Especially I didn't define here because that is not given. So in the doc, I did not see it anywhere. So, but it is an internal memory limit were placed on ad hoc workloads, and also the query store hints, like I mentioned. So before going to the intelligent query processing, let me share my demo. I actually recorded my demo. So I would like to share my recording because I have to tell you, I have a lot of good things going on here today for me. I try to change my, we get an if we are an MVP, we get an MVP MVP portal, and then we get some credits where we can test our lab environments and everything. So what happened was like my authentic app, uh, like the Microsoft authentic app failed on me, and I tried to fix that. It didn't work. So I had to completely delete that app. It didn't work. So when I contacted them, they said like, how about you using a different email? I used a different email. Well and fine. I got it, everything, emails and everything got set up. But the thing is, all the demos that I have created and all the environments, Azure SQL databases that I have, everything was lost along with that previous email. So it's a terrible news for me. I have to rebuild everything from scratch now, but glad I recorded my thing ahead of time so I can show you that. So once I will place this running and I will stop for a minute and ask you if you can able to hear me. So let's see the demo on how the query. Are you able to hear me?
Yeah, everything okay.
Yeah.
Okay, the recording is also audible, right?
Yeah, visible.
Good.
Yep.
Query store hints actually work. So here I'm using the Azure SQL database, and we are using the AdventureWorks database here. So as I mentioned before we have like, if you're not using the query store hints, if you do not have a query store enabled on the database, and if you are not in the SQL Server 2022, how do we actually resolve the problem? If you want to use any hints, if you want to use any query hints, this is how you used. You actually modify the query itself, and you use the option and use any of the hints. Like if you want to recompile, you use it option recompile, or use any other hints. Like for example, query optimizer compatibility level, you are using 110, but you are actually modifying the query itself if you observe here. But if you are using the query store hints, then you do not have to modify the underneath code, but you can use the query store hint store procedure to make that happen, to enable the hint. And so we are going to create a little store procedure here. I'm dropping the store procedure if it actually exists, and then create the store procedure. All I'm doing here is selecting couple of the columns from this table where the product ID is product ID parameter value here. I'm going to create this on the database AdventureWorks and execute that. Um, though I'm running this demo on the Azure SQL database, this is the same exact um, demo that we can also use on the SQL Server 2022, because this feature is already enabled in the Azure SQL, and then they enabled it on the SQL Server on-prem. So I'm going to clear out the query store here, and then I'm going to also clear out the procedure cache here. So I have created the store procedure, and now I'm going to execute these two store procedures, this store procedure with two different parameters, the same store procedure, right? So I created the store procedure and I'm running this execution for the first time, right? After creating the store procedure. Now let me enable the execution plan on and execute it. So the query is running, and let's see the execution plan. Now, if you see the execution plan, currently it used clustered index scan here. But if you see the results on the first execution, it produced like 360,000 records, right? 361,000 records approximately. And the second one, if you see the results, it's only 385 records. So this is a parameter sensitive problem here. But the first time, as it executed with that particular parameter value, with this parameter value, which generated 360,000 records, the plan got generated and it got saved inside the plan cache. Now the second execution just produced 385 rows with this parameter value, but it still used the clustered index scan, which is which we do not want here with this only little number of records that we actually received, 365 records. So why does this happen? This is the normal behavior, right? This plan got created with that parameter value the first time we executed with that particular parameter value 870 is a very sensitive because it produced too many records, but most of my parameter values just produce couple of hundreds of records. But as I executed this with this parameter value, For the first time after I generated the after I created the execution, after I created stored procedure, this plan got saved inside the plan cache, and now we don't want that to be reused because most of my parameter values will only produce couple of records. So how do I resolve that problem? If I do not have the query store, I would have used the recompile option, right? But by using this query store hints, what we can do is we can get the query ID for this particular query by using this query and filtering out on the query text itself. And I'm running this to grab the query ID value, which is 3, right? And now I'll go ahead and run this particular store procedure designed for the query store set hints, and the query ID which we got is 3. So I have to enable query ID 3, right? And then I use the values, parameter values, two parameter values here. One is query ID and the other one is value. What um, hint value you want to use? I want to use option recompile here. And if I enable that, right, by using the query ID 3, after executing that and then rerunning these executions again to see how it works. Now the same executions again. This time it uses the clustered index scan, but the next time it used index seek and the key lookup this time. That means it clearly used the query store hints. And you can see whether it used the hints by going into the properties. And you can see that it used the hint value, the query store statement hint, option recompile. It has been used. Now let's go ahead and see in the query store. Once we refresh, we have the query store, and we can see the top resource consuming queries here. This is the exact graphical user um, interface reports that we actually have by default, where you can take the advantage of seeing these reports. But this is in the graph model where I need to hover my mouse and see the query. But I would like to see it in the list format, right? So I can click on this little icon, view top resource consuming queries in grid format, so that it will give me the list of the query ID. And if you can see, there are two execution plans that got created for this one query that we executed, the store procedure. But if you see, if you hover your mouse, you are seeing it in the parameterized format, and you don't see the parameter value here that you use. But you see the two different execution plans that got created for those two parameter values. Now, um, now as we use the hint, right? We have used the hint and it produced a new execution plan here. Now, to see what all hints are enabled on my database, I can just run this query. Now, if you see the query hint ID is 4 and the query ID is 3, and then what hint was applied. But if you observe here, it shows the query hint ID 4. What about the query hint ID 1, 2, and 3 that I used previously in my previous demos? So it is showing me query ID, hint ID 4, but not the history of the information. So by default, this information is not captured in the SQL Server query store views. So to get that information, history of the information, you need to enable the extended events. I have written a blog post about how to enable that, how to use the extended events to collect the history of the information of these query hints. You can see my blog post dbanuggets.com to actually see how to enable that. So now let me go ahead and use some other different hint ID. This time we are using max.1 on the query ID 3. Now we are actually mm, thinking of using different hints, right? We are exploring the options, what we have here. So we are using the examples. Now I enable the max top one and I will clear out my cache and I will execute these two executions again to see how it will work this time. Now, if you observe, it uses the clustered index scan. The first one, it created the clustered index scan because of 360,000 records, and the same one used because this time we are using max top 1. Now, if you see the properties here, the max top is set to 1, but we also want um, recompile because we don't want clustered index scan all the time. We want to use two of the hints. Now, as soon as I changed the hint, it override the existing one. It did not keep the actual one. So that is the reason we need to append instead of instead of like overriding by removing the actual uh, hint. We do not want to remove the hint, the previous hint. We want to append. So here we are using both of them currently. The query ID is 3, not 1. So we are running that. And this time we will see if both of the hints are applied. If you see here, now this time the clustered index scan as well as the index seek and key lookup is applied. Now if you see the properties, you can see the max top 1, max top set to 1 as well as the query store statement hints, both of them are being used. You can clearly see it here. That's how you can use the multiple query hints at the same time. Now, if you want to clear out the query hints, you can use the SP query store clear hints and use the query ID to clear out the hints. But make sure, like when you are doing this, you are losing the history, right? Clearing out. That means the hints are no longer applied as well. But if you have the extended events enabled, you can collect that information. And now if you run this, what are enabled currently, what hints are enabled currently, you can see the results, none here because we just cleared out the hints here, right? That's how you can use the query store hints. We never touched the actual query itself, but we use the SP query store set hints and SP query store clear hints to clear out. And for all the hints that are being currently supported, please go ahead and visit this website to see them. Now, I would like to also show you how the parameter sensitive plan optimization works. Okay, so I think I will show you that again. Did I close that one? Okay, so from current. So intelligent query processing, there are several like additional features that got introduced. But if you see right side at the bottom of the screen, we are focusing on the dark blue SQL Server 2022 features. So one of the feature is parameter sensitive plan optimization. We have all of these, but we are going to touch most part of them, if not everything. So the highlights of using these IQP features is nothing to use them, right? To use them, all you have to do is change the compatibility mode of the databases after you migrate or create any new databases. Make sure the compatibility level is on SQL Server 2022 so that you can go ahead and use that all of these IQP features. That's all you have to do, change the compatibility mode. And multiple IQP features can work together. It's not like only one can work at a time. Multiple can combinedly together work. So where did I capture this? Query store advancement, we have already talked most part of it. But the other thing is, again, it's in the preview mode, but the query store can can actually capture the information on the secondary replica as well. Not only the primary replica, previously they just have to They just used to collect the information on the primary replica, but now they can also collect the information on the secondary replica. Now you might be having the question, now what, like if it collects the information on the read only, how can we actually make the changes? Like how can we enable it on the secondary because it is read only? So any changes
So
that
you
we
mean
do,
the secondary read-only version, right?
secondary
Or
read
a
only
tertiary?
version.
Okay, thank you.
Yes.
Sorry.
Yeah, secondary read-only copies, right? You cannot enable it on the secondary read-only copies. You have to first enable query store itself on the primary read-write replica, then enable it from primary itself on the secondary replica. So there are certain store procedures that you can use to actually enable either on just the primary or just the primary as well as secondary or just the secondaries. You can use the store procedures to actually do that, but currently it is still in the preview mode. It didn't went into the production, and even though if you wanted to try it out, you have to only do it on dev environments. And the other advancement of this query store is all of these IQP features that I just listed it out, and here you can see except the parameter sensitive plan optimization. The rest of the features, which is memory grant feedback, degree of parallelism feedback, cardinality estimate feedback, and optimized plan forcing, all of this uses the query store information. It will analyze the workload over time because query store will collect the data over time. So all of these IQP features will depend upon the query store information, and then they will analyze and then make the decisions based on that. So let's talk about the parameter sensitive plan optimization. So it is also known as PSP optimization. It doesn't depend upon query store. If if anybody asks you what is the only IQP feature that doesn't depend upon query store, that is PSP optimization, right? So when they introduced this PSP optimization in SQL Server 2022, there are couple of things that got introduced as well, which is dispatcher and variant plans that we need to know. I'm going to talk about that. So, so let's talk about like we have this dispatcher plan and variant plan. Dispatcher plan is something that um, you have all the logic in it. Dispatcher plan, like for example, if you run a query, if you run a store procedure, and if you have several parameters with different amount of data that you receive, like some parameters again hundreds of records, but some parameters gives like like millions of records. Then once you run those sort of store procedures with different parameters, dispatcher plan will actually capture that information. It has the logic in it. For example, um, if there is, we have taken in this screenshot, you can see the flow, right? Just like the indexes that you have, like clustered, non-clustered indexes trees. We have the tree here as well. For example, if we are searching, um, if we are running a store procedure, and inside the store procedure we are searching on an agent which have like less than 10,000 listing. If we are searching on that, right, agents with 10,000 listings, it will only give less than 10,000 records. So the less number of records, let's say. So and also you have different set of values which will produce different results. And also there is like we are searching also on the agents which have more than 10,000 to 1 million listings. 10,000 to 1 million. And then there is one more search where we are doing like agents pull everything up which has more than 1 million listings. Now the dispatcher plan will analyze the incoming parameter values, searching on those parameter values, and it will have a logic in it to build the different plans for these three different parameter values. Again, it depends upon the skew of the data that you have in your database. It will save. inside the dispatcher plan up till 3 execution plans. Until SQL Server 2022, we have just one execution plan. One execution plan that will create, and the next time the SQL Server runs the same store procedure, it will go ahead and check in the plan, just like the way we saw that flow diagram in the beginning of the session, right? It will go ahead and check if there is already plan, and it will use that plan. And if it doesn't find the plan, then it will build the plan. But here it is different. With not only one query plan is saved, but based upon the flow of your data, it will save up to 3, not more than 3, but up till 3 execution plan per query. So that will take more space in your in the memory, we understand, but this parameter sensitive plan optimization will solve the parameter sensitive problem because it is already saving 3 different plans in the cache. It will go ahead and choose that automatically, and most of the times it should resolve the parameter sensitive like problem. So let me go ahead and show you a demo on it. um, Let me show you .mp4 I have recorded, right? I don't know. Let me do that by myself. I think I can do this demo. I already recorded that, but also I can show you here. So we are using SQL Server 2022. Let me connect to the server. All right. So we are using Stack Overflow 2013 database here. This is not the server. This is the server. So we are using this. It's a 2020. So we do not need the PSP optimization to run, but then I just placed it over here. I don't know. I thought of like showing how to enable because we are seeing this one here. Let me also go through a couple of more things that you have to know while using Query Store. Very important. So there are a couple of modes actually. When you are using the Query Store, when you are enable Query Store, you have read write mode. If you select that read write mode, then let me show you actually what I'm talking about. Right click database. If you are in SQL Server 2016 or above, you'll be seeing this query store icon here where you can go ahead and search. So here you have read write mode. Read write meaning like you can read and write. You can read the force plan information. If you are using any force plans, you can read that. SQL Server will read that as well as write any new information to the query store. If you select only read only, right? If you select that option, all you can do is like if there are any force plan, SQL Server will only read those force plan. It will not write anything. And there is also off button. If you turn it off, nothing will be captured, right? And also the data flush intervals. If you remember properly, every 15 minutes, collected information will be pushed to disk, right? That is one. And maximum plans per query is by default it is 200 plans per query. So that's by default. You can also change that. Maximum size in MB from 2017 and above, I believe it is 1 GB. So again, it is based upon your database sizes and everything. You can do that. Capture mode, you need to know those 4 modes. What are the 4 capture modes? Is like all by default. Everything will be collected. If you are in SQL Server 2016, everything will be collected. So even the least insignificant queries, even those will be collected. So it is not recommended. And from 2017, they made a standard, and by default, they made it as auto. Because by auto, if you are choosing auto, then the query has to run certain number of times, as well as it has to reach certain threshold value of CPU to be entered into the query store. So those values we do not know, that is not released. But from 2017 and above, they have actually added custom policy. So when you click on custom, they will you will be able to actually um, select by yourself, like execution count, how many times your query has to run to be captured in the query store, as well as what is the total compile CPU time it have to hit, as well as how much total execution CPU time it have to hit, right? You can choose that. So a stale threshold 1 hour, you can also choose that. So um, those are the main configuration settings that you have to know. Again, very important. And um, so interval length minutes is 15 minutes by default. Every 15 minutes by default, it will create a new interval. And no matter within that interval, how many times your query runs, it will only capture one record inside the query store. So that thing you have to remember. So I just put this together so that um, you know. So to show you how it will work. So parameter sensitive plan optimization is automatically turned on when you are in SQL Server 2022, but you can also manually turn on by using this. Alter database scoped configuration, set parameter sensitive plan optimization as turned on. Once you turn it on, it will turn on. I have to run it on the database, of course. So um, and then I have to place the database in 2022, right? I did that 2022 compatibility mode. Now I'm creating a very small store procedure here. If exist, I'm dropping off and then creating new. All I'm doing is selecting star from DBO users and I'm searching on reputation, order by display name. Very simple. Let me execute that. If you are familiar with using the Stack Overflow database, DBO users is an excellent table to do your demos with. So now what I will do is, if you see properly here, I am searching on reputation column, right? So whenever SQL Server is running a query, it will actually go ahead and see the statistics, see table statistics on the columns um, in which on what you are searching on, right? We are searching on reputation, so it will go ahead and directly search for the SQL Server statistics on that particular column. So here I would like to show you the statistics itself of the reputation column within this database. So if you see here, statistic is nothing but it's a table, it's an internal table which will either be created manually when you create it, or it will either create automatically when you are searching for the first time with a where clause. If you are searching on that column by using the where clause, then it will go ahead and automatically create that statistic. Statistic have up till 200 rows, not more than that or less than that. Here we have 194 rows. So why I'm even showing this, right? I'm going to show you the type of, like, the level of skew we have in this column. Now, if you see the rows, um, when I mention range high key, that means like the reputation value itself. For the reputation value 1, we have these many rows. For the reputation value 11, we have these many rows. So SQL Server will automatically go ahead and search for these values inside this statistic, and it will grab that information, and based upon this information it will allocate the resources to run the query, right? So we have lot of information here, and from here I took the range of the parameter values so that I'll have like different set of output values. For example, 5714, if you see in this result, it should be somewhere in here. 5714, if I hover my 5714, if you see here, the reputation value 5714 have only how many rows? 8 rows. Okay. Now I took that value because I'm running it for the 3 times, so that it will only give me 8 rows. Reputation 1, we have seen it have some million rows. What about the reputation 13? Reputation 13, let me see here, somewhere it should be here. Reputation 13, it is giving us equal number of 26,000, 26,226,000, right? So let's go ahead and run this workload, right? We are running a workload because we are running 3 times, right? Let me go ahead and run that by enabling the actual execution plan on, execute it, and see the execution plan. Um, Now it looks like it created equal plans, similar plans. Let me execute it. It's still executing actually, because the first one will go 3 times. So I thought we are running just one times, but we are running multiple times. So the first one will generate the similar plan, right? But then the next one, if you see, it is giving the clustered index scan, clustered index, clustered index. And the third one executed 2 times, and it looks like the similar to the previous one, but it is not. It might be similar, it might not be similar. So let's go ahead and see. Did you observe the difference? Like previously, the first execution, the first execution with this, whatever plan is generated, the next execution should use the same execution. But no, it didn't. It it produced the new execution plan. Now, if I see in the plan cache, when I run this query, I can see the actual plan cache. Plan cache didn't give me any information. I don't know why it didn't give me any information. Um, no, it is not giving me. So it will actually contain uh, the plans itself. I don't know why it's not giving me the results. I don't know. Let's move on and let's see this one here. By running this query, actually, I think it should produce again, I'm using the query store, right? Query store information here. And then pulling up the information here. So execution count 3, the query text and the query hash values and everything. I can see by running this information, again, this is being captured. You can see the query plan information and text everything. I would like to actually show you the plans itself. Let me run this. Um, Let me run this query. I think one of these queries is useful to show you the dispatcher plan and variant plan, because we know that multiple plans are created. So I would like to show you the plans itself, how they got saved inside the dispatcher plan. So this is the dispatcher plan and these are the variant plans. Now dispatcher plan, if you hover your mouse, you can see the plan, show plan XML. If you click on that, it will show you the multiple plan. If you see, you can't actually click and open and see anything in it, but then it has multiple plan. That is what for this particular query. And if you see the rest of the plans, we have 3 variant plans. Variant plans is nothing but the query plans itself. So we have 3 different query IDs here. I mean the plan IDs here. And then you can see the plans. When you click on that, you can actually see the plans. So as you are in SQL Server 2022, Query Store is actually enabled. So you can get that information from the Query Store as well. But it clearly shows the variant plan and the dispatcher plans here. Dispatcher plan is just one plan, but 3 different variant plans up till 3 I mentioned, and all the 3 have 3 different plan IDs, meaning they are 3 different plans, right? So by using this PSP optimization, we will be able to resolve the parameter sniffing problem most of the times. So let me go ahead and show you, talk about like memory grant feedback. Like I mentioned, I showed you the demo of the query store hints and the PSP optimization. Now let's go ahead and see about this memory grant feedback, persistence and percentile. So before going further, I would like to show you a couple of like internal processing, how the SQL engine does, um, because
Hey,
that is very
Deepthi,
important. Yeah. Are
it
we
is
running out of
top
time?
of, no, no, what I'm saying is it is top of the hour in
Okay.
case you made any other commitments, but yeah, feel free to go on. Okay.
Yeah, sure. Yeah, we do not have any more demo, but the next slides are a little bit important to understand. But as per demo, we are done with the demo. So I'm going through the slides. I'm okay with by going couple of more minutes. So if you are interested, please go ahead and listen. So the query execution, right? Whenever a query executes, we already saw this in the initial slide, but I would like to show you a couple of other information here. So how the SQL engine actually designed the execution plan and how these memory grants are really important and how they are used. So whenever the query executes, right, it will go through the transformation phase and design multiple execution plans. And based upon each of the statistics, cardinality estimates are nothing but the statistics within your tables. Engine will go ahead and check these statistics, just like the way we have seen the reputation column, right? It will go ahead and check all of those estimate values, and whatever plan has the lowest cost information, cost meaning like not the money, but the cost is based upon the resources. Whatever take the low resources, then that will be the winner, and that plan will be saved inside the plan cache, right? And now the query uses that plan cache, and memory grant will be actually allocated based upon those cardinality estimates only. Now, if at all the query has to produce 1 million records, but our statistics are stale and we didn't update them properly, and only it shows like 13,000 records are going to be like when you execute this query, only 30,000 records will be shown up because that is what I'm seeing in the statistics. If that is the value that is being seen in the statistic, only resources are allocated for that 30,000 records. But in fact, when you are executing the query itself, you are getting 1 million records. Now, if you see the difference, now the memory grants are allocated only for 30,000 records, right? Now, that memory grant information is also stored inside the plan cache. Now, the query goes to the execution phase using that plan cache with all the memory grant information which is already saved inside that plan cache. Now, what if the memory, like I mentioned, that we have the stale statistics, we didn't update it properly, and all the information is wrong in there. Now, that will affect the cost because based upon that, the resources are allocated and the lowest resources will be the winner, right? So the wrong costing will be done based upon those estimates, and wrong plan will be saved inside the plan cache, and wrong memory grants are allocated, and execution will take time based upon how many minutes it have to take. We didn't have the proper resources here. Now it will have hiccups, and it do not know what to do because once the query plan is being used, we can't allocate more resources right on the time. It is already saved inside the plan cache. We can't do anything during the execution phase. So that's why most of your queries, if you do not have proper statistics, it will keep on running, and it will throw error, whatnot. The execution will take several minutes, sometimes hours even, right? Now, all of this I'm talking because of the stale statistics, the cardinality estimates being wrong. Now, that is the reason why the interlink between the statistics as well as the memory grants. If the statistics are proper, the memory grants that are allocated will be also good. So it is based upon the cardinality estimate. Query can take more memory or less memory, like I showed you. So the goal here in SQL Server 2022, the improvement is that they just now, for example, if your memory grant is less, but you need more memory to execute the query, it will have to spill to disk. That is the worst thing that can happen, right? It can spill to your tempdb, all sort of things can happen. So in 2022, based upon the query store information, memory grant feedback will be used that information, that query store collected information, and it will try not to spill to the disk. That is the goal here, right? And also allowing other concurrent workloads because if the spilling is not happening, the other workloads can also run because it is not taking more resources on TempDB. So in SQL Server 2017, we have batch mode processing. In 2019, we have row mode. But in 2022, all the information that is being captured by the query store and this feedback, the memory grant feedback, will not be lost even upon the restart. Before that, only upon the restart, everything is cleared out before that. But now, because we are using query store again, that information is being persisted and not lost. So something else we need to remember here. Um, So before SQL Server 2022, memory grant feedback used to only depend upon the last execution only, the last execution. But with the SQL Server 2022, because we are not only depending upon the last execution, we are looking at the history of the um, feedbacks that are being used in our queries. It will actually evaluate the queries and it will look for the not only look for the single last execution but multiple last execution, and it will take the average and then allocate the memory grant feedback on the top of your queries. So when that happens, the proper memory grants are allocated, and since it will persist even upon the restart, this feedback is really beneficial. And once you start running the queries, right? And if you are in SQL Server 2022, when you see the memory grant information in your execution plan, sometimes it will show you as adjusting. Sometimes it will show you as adjusted, which is already all the memory grants are allocated. Most of the time it will take your fee like it will take the workload of your queries and it will adjust itself, not based upon the last execution but multiple executions. So that is the advantage. It will look the history, everything that I mentioned here. The previous one used to work on only single execution. If you see the graph, it is going up down up down. If the last execution a memory grant is not good, the next execution will be affected because it is based upon the last execution. But here in the SQL Server 2022, if you see the graph, it is on the top, right? It will only try to maintain the memory grant that is actually required, not less, but also not more. It will not go overboard. It will look at the history and it will maintain the memory grants. Cardinality estimate feedback, like I mentioned, how important the estimates are. There are certain techniques that are used in SQL Server 2022. I do not talk about that much here because it's a lot of information. You can go ahead and look into the Microsoft Docs if you'd like to. But based upon the estimates, not only the memory grants are dependent, but also what type of operator should I use within the execution plans are also dependent, as well as how much CPU needs to be used also is dependent upon the cardinality estimate feedback. So by using certain techniques, which is like predicate independence versus correlation, like for example, if you have a correlation between your columns, like for example, city, zip code, state, these are all related, right? Now, if a SQL engine have to see that related information, it is beneficial for it to change that to the in predicate independence, look them separately instead of like correlating these predicate values. That will actually help and in processing the queries very faster. Again, I'm not going in deep in this information, but I'm just mentioning. And also um, it will also check for the containment, which is nothing but the joins, how the query is actually being joined in between the tables, and also the roll call. Based upon that, again, it will use the query store information, and based upon the feedback, it will use the cardinality estimate feedback and analyze and then verify and then um, use the information to give the proper estimates, changing the cardinality estimation. So to use that, you need to use 160 again SQL Server 2022. Only repeated queries with the persistent plans will be considered. Verified only upon the feedback. The feedback will be implemented only upon the verification. And again, it uses the query store hints. DOP feedback, degree of parallelism feedback. So if your queries, right, if your queries are using max stop value too high, but your queries doesn't require that, degree of parallelism feedback will actually, again, it will use the query store feedback and it will reduce the max stop value up to 2. It won't increase, but it will only decrease. That is the important point we need to remember here. It won't increase. It will only decrease up till 2, value 2, again, based upon the feedback of query store. So I covered the IQP features, some of them demos, some of them just by talking about it. But these are the references. It's a very big topic actually. So we couldn't cover here in just in 1 hour, but it will take at least a couple of hours to cover everything. But if you want to know more, please visit this website, websites and resources to know more about it. And I would like to um, thank Ola, for moderating my session, and thank you for giving me this wonderful opportunity.
Absolutely, Deepthi. Thank you. Let me stop the recording though.
Sure.
Okay.
Thank you, Deepthi, for this really interesting and detailed topic. If anyone have question, you can ask loudly or in the chat.
Mhm.
Now I see just a lot of thank you.
Thank you. Yes,
Thank you.
obviously.
Yeah.
I am in a pressure today, to be very sincere.